Have you ever wondered how tunnels are built? The answer lies in a complex construction process called tunnel boring. Tunnel boring involves the use of a massive machine called a tunnel boring machine, or TBM. This video discusses about the construction process of tunnel boring. These machines are designed to excavate tunnels through various types of soil and rock. The first step in the tunnel boring process is to prepare the site. This involves setting up the TBM and constructing a launch portal, which is where the TBM will begin its excavation. The portal also serves as an entry point for workers and equipment. Once the launch portal is complete, the TBM is lowered into the tunnel and begins its excavation. The TBM consists of a rotating cutting head, a series of hydraulic cylinders, and a conveyor system to remove excavated material. As the TBM advances, it excavates the soil and rock and pushes the excavated material onto the conveyor system, which transports it to the surface for disposal. The hydraulic cylinders push against the tunnel lining segments, which are installed behind the TBM as it advances.
With its rotating cutting wheel, the tunneling machine breaks the material from the tunnel face. The material is then transferred to the belt conveyor system in the rear of the shield via a screw conveyor, while the hydraulic cylinders press the machine forward continuously. The reinforced concrete segments, known as lining segments, are installed under the protection of the shield skin. When the ring building has been completed, the machine can push itself against the new tunnel ring and drill further into the soil. The 83-meter-long backup accommodates all logistic facilities necessary for the operation of the overall system. The working method of an EPB shield is basically made up of two phases: the tunneling phase and the ring building phase. During the tunneling phase, the cutting wheel, which rotates at a speed of up to 2.7 revolutions per minute, is pressed against the tunnel face with a pressure of up to 400 bar by means of hydraulic cylinders. 24 hydraulic motors drive the cutting wheel via a gear rim, developing a drilling torque of up to 38,000 kilonewton meters. Under this high pressure, the disc cutters and cutting knives made of high-strength steel loosen the material at the tunnel face. If necessary, the soil can be conditioned with water, bentonite, or foam using the injection systems located on the backup. With the help of nozzles integrated into the cutting wheel, the corresponding conditioning medium is injected into the soil, which is pressed into the excavation chamber by the existing earth and groundwater pressure. For shield tunneling in non-stable soils, a loss in stability at the tunnel face is compensated by creating a support pressure. In the case of the earth pressure balance shield, the soil which was excavated by the cutting wheel is used to support the tunnel face. In order to reach a state of equilibrium, the support pressure is transferred by the hydraulic cylinders via the bulkhead to the soil, which avoids an uncontrolled penetration. The soil prepared in this way can now be transported from the invert area of the excavation chamber to a belt conveyor by a screw conveyor. The screw conveyor is driven by two hydraulic motors which have a power of up to 400 kilowatts. The quality of the soil taken from the excavation chamber is regulated by the screw conveyor's rotational speed, which is matched to the advance speed. The aim is to maintain a state of equilibrium between the quantity of soil removed by the screw conveyor and the quantity of soil accumulated from the shield's tunneling process. This guarantees optimum support for the tunnel face. The system must be able to react flexibly to the permanently changing geological conditions. Therefore, the current state is continuously controlled with the help of pressure sensors, by measuring the cutting wheel torque and the screw conveyor torque, and by monitoring the excavated material. When the tunneling phase is completed, cutting wheel and screw conveyor are stopped. Now the ring building phase starts in the shield area under atmospheric pressure conditions. A complete tunnel ring consists of several segments, called lining segments. These prefabricated reinforced concrete elements are produced with millimeter precision in a factory which is especially installed above ground for this purpose. Following quality control, they are then transported into the tunnel by mine cars. In the front section of the backup, the lining segments are lifted individually by a special transfer crane. It lifts them onto the segment feeder which transports the elements to the front of the tunnel.
The tunnel lining segments are precast concrete sections that are installed to line the tunnel walls. The segments are designed to interlock with each other, creating a smooth and sturdy tunnel lining. As the TBM advances, the tunnel lining segments are installed behind it. This process is called segmental lining. The TBM is designed to install the segments automatically as it excavates, reducing the need for workers to enter the tunnel. As the TBM advances, it creates a circular tunnel. The size and shape of the tunnel depend on the TBM's cutting head and the diameter of the tunnel lining segments. The excavation process continues until the TBM reaches the end of the tunnel. Once the tunnel is complete, the TBM is disassembled and removed from the site. The tunnel is then inspected to ensure it meets safety and quality standards. If any issues are identified, they are addressed before the tunnel is opened to the public. And that's the tunnel boring process. It's a complex construction process that requires skilled workers and advanced machinery, but it's also essential for building tunnels that connect communities and improve transportation. Thanks for watching. We hope you learned something new about the tunnel boring process.